Well, hey there. Good evening, everybody. Welcome to Take-Go After Dark. We are excited to have you with us tonight. I'm John Barba, joined by Rick Mayo, and we've got a great program for you tonight. And again, thank you so much for taking your Wednesday night out, taking time out of your Wednesday evening and spending it with us on this computer machine here on a little webinar. So we are hopeful that everything's going to work out all right, and you'll get a really good program delivered to you by Rick tonight on domestic hot water. So it's going to be an awful lot of fun. An awful lot of fun. So what is the topic tonight? Let's get right to this. This is episode 4 of our summer sessions, and it is the real reason why sizing your Recirc pump is important. And as always, our patron saint, Bruce Campbell, the most interesting and coolest man in America, is right on top of that. He believes that pump sizing, Recirc pump sizing is very, very important, and he wants you to know the real reason. So that's where we're going to get to tonight with
Cool.
our man in charge here. And tonight's movie theme, of course, we have one every week, and it's again one of my favorites, Butch Cassidy and the Sundance Kid. Butch and
Perfect.
Sundance, right again. And the way it works tonight is I'm going to be Butch, and Rick, because he's much better looking and far cooler, he's going to be Sundance. All right.
Wow.
Hey, there you go. And you're probably wondering, well, what Butch Sundance? What about Dave? I mean, he's not going to be Yetta. That's not going to work out, right? He's not at a place. That's just weird. Dave's got a little back injury thing going, so Dave's not here, man. I'm
Dave
sorry.
not here.
Dave's not here. He's kind of laid up, real bad back, and I talked to him today, and he's still in a lot of pain. So I said, you know what? We got this tonight. We got this
We do.
tonight. So think of Dave and give him your best. All right. Couple things real quick. Again, control panel. Want to make sure we're all on the same page here tonight. That your orange arrow on the right-hand side, make sure it's pointing to the right. If it's pointing to the left, well, just click on it and everything will expand, and you'll see your audio selection stuff. So hopefully you can hear us. Okay. You've got handouts to download. Okay, those are there for you, so you can download your handouts. That we do have plenty of them. Actually, there's 5 of them tonight for you to download that Rick has put together for you in support of this presentation. So please make sure you download those. You can do those at any time. Is that right, Rick?
Yep.
Okay. So you can go ahead and load those now for your use. And the most important part, of course, is the questions and chat section. So why don't you go down there real quick and just type in a hi, hello, how are you for me, and let us know how you're digging Butch and Sundance, okay? If it was appropriate, you know. So we got a hi, hello, how are you from Travis? Very good. And Bob Dressler, Rich McGrath. So I'm guessing everybody out there can hear us.
Good.
Real important, folks. Sarah, thank you very much. This is going to be how you're going to ask questions throughout this presentation, folks. So please make sure you're comfortable with the process. Ask any questions as they come to you, and we will address them as we go along. Every couple 3 slides, we'll take a quick look see and check out the questions, and we'll address them as they come up. And then, as always with Take Go After Dark, we'll stay on as long as you guys want to answer whatever questions you want after we're done. We've done this show we've had shows that have run over 2.5 hours, so we don't care. We're good. We block out our Wednesday nights for you guys, so the least we can do is stay on as long as you guys have questions. So
Yeah.
that's going to be how that works. If you're on a computer, if you're on a desktop, if you're on a tablet or a phone, it's going to look a little bit different. So you still have your buttons down at the bottom. One can be to toggle between webcams and presentation. I got to believe you'd prefer the presentation than looking at our 2 ugly mugs. Your audio settings are there as well. And then the little question mark on the side, again, that's where you'd ask questions on a device, on a tablet or a phone. So without any further ado, we have one
Indeed.
more thing we want to throw out at you, and this is a new and not new. We've been doing it ever since we started the Takeo Summer Series, Takeo After Dark Summer Series, and because of our sponsor, our co-sponsor, MechanicalHub.com, we have brought along a special segment called "Where is Eric?" Where's Eric? Eric Awney, a great plumbing and heating guy from Minnesota, a dear old friend of mine, and co-owner and guiding spirit for mechanicalhub.com, has been invited to every single Take Go After Dark we've done going back over 2 years, almost 2 years now. Hasn't made one yet to be a co-host. Hasn't made one yet. He's a busy guy. He's a busy guy. Actually, the entire Mechanical Hub crew are busy right now. They're at a factory in Minnesota doing a tour. They're doing their day job, so which is pretty cool. So none
Yeah.
of them are with us tonight, unfortunately. But we still want to keep in the where's Eric spirit. So the way we play it is this: I'm going to show you a picture of somewhere in the world where Eric is, and your job is to guess where he is. And when you guess where he is, type it into the question section, and everybody who gets it right, we're going to enter you into a drawing for a T-shirt, a Takeo After Dark T-shirt, just like the one that Rick Mayo is modeling for you. So that's going to be what you're going to win. Okay, so make sure you get in on that one. And we also have a trivia question for a really cool prize as well. So your participation is going to be very fruitful for you. I'll tell you what.
Yeah.
So where in the world is Eric? Let's see what you can come up with. Where in the world is Eric Awney? All right, I'm going to leave that up there for just about a few seconds here. Take a good look, see what you think. If you can figure it out, once you got it figured out, just type it on in and let us know where you think our man Eric Awney is. Eric's been getting around. Last week he was in where was he last week? He was in Machu Picchu, Peru.
Pichu. Yeah.
Right. The week before that he was in Moab, Utah.
Ah.
At the bridges, the sand bridges out there.
Yeah.
And his first week, he was at the Fontainebleau Hotel in Miami. So Eric do get around, that young man. He does get around. So if you know where he is right now, type it on in, and you will have a chance to win a Tikko T-shirt. A Tikko T-shirt.
Great.
All righty. We're going to move on now, but if you still think about it, type it in. You can type it in for the rest of the evening. That's okay, where you think Eric is. Eric's hiding today. And with that, I'm going to turn it over to Sundance. All right. You ready, Sundance?
Sundance.
You ready,
Let's go.
Sundance? All
Let's go.
right. You have the con, man.
Show my screen. Shrink a couple things down. And kill that. I think we're ready. I really do. Boom. Okay, folks. So we've actually done this session before, but it's very important to understand what we're doing with domestic hot water recirculation. And so it's even if you've sat through something like this before, it's worthy of sitting through it again, only from the standpoint that both John or I or Dave, we don't always do the same thing with that session. We might change it up a little bit. So bear with us, and I think you'll come away with a better understanding of the concept. And again, it's not going to be about memorizing a bunch of numbers or anything, but there's these concepts that you can walk away with that'll keep you out of trouble. Okay. Name of this session, well, I should say this is a segment out of about a 4.5-hour session of domestic hot water design and application and all that stuff. We're just pulling out some, tidbits to wet your whistle, so to speak. Maybe someday we'll be out and about doing those, half-day sessions like I just mentioned. So for now, again, just wetting your whistle. What I'm going to try to get done today is just let you know that there are problems within the industry associated with people not understanding what to do with domestic hot water recirculation. Okay. Again, we want you to not be mystified by what size that circulator should be. A lot of people just say, well, I've told, that I use this one on every job and it just seems to work, so there's a little more to it than that. We want you to get a little bit more out of it as far as understanding is concerned. We're actually going to give you a nice little tour through our Size Right Domestic Hot Water Recirc app, which is a very simple little thing that we put together over the last few years that's still a work in progress. It's one of those things that, if we get some information that we can make it better, we're absolutely going to do that. So we'll let you look at that. I'm going to do a quick little example for you so you know how to use that. And of course, as John's already mentioned, we'll have some handouts that'll help you. If you really want to know what to do with domestic hot water recirculation, these handouts are there for you, and they will help you if you have an idea. And I'll go through them as I come upon them. I'll show you. Okay, this is a handout, and this is what you do with it, so to speak. So Let's go ahead and take some a gander at some homemade unwanted sprinkler systems. Okay, if you can actually see right here, you can see right into through that pipe, I should say, velocity, erosion, corrosion. You folks have heard of that. We're not selling sprinkler systems, and by no means am I picking on the copper folks here, right? My next few slides are going to show some plastic pipe as well. But understand, these are just things I've found online just with a simple web search. You can too if you want to dig into this. You'll find a lot more pictures than what I'm throwing on here right now. Here's, as mentioned, plastic folks have had issues when people don't do things with the correct understanding. That's why we're going to spend some time on some of the real important little bullet points that you should walk away with this evening's session. So there you are with some bigger green pipe, some polypropylene. So we showed you some polyethylene PEX specifically. We showed you some polypropylene. We showed you some copper. And again, nobody's immune when things go wrong, this perfect storm scenario. And we'll make sure you understand what those are. What are those things that when they come together cause problems within systems? Okay. Cause and effect. Okay, let's look at it that way. I'll point out 4 of these contributing factors. Again, this is just to get your concepts down, to understand, hey, this stuff is happening within our systems. And the first one I'm going to bring up is we're starting to see the temperatures elevated in domestic hot water systems for various reasons. But one of them is, and we don't pretend to be the Legionella experts by any means. We just know that some of the codes that are out there now, some of the ASHRAE stuff like 188, some of the things with, even some of the other organizations that deal with health, CDC, some other things, are looking at issues with these waterborne bacteria, these little critters that float around and actually come out into the airstream when we shower, when we're running water, etc., and cause some problems. Now, one of the ways to deal with that is thermally. Okay, so as you can see, this little thing talks about Legionella growth range being anywhere from 68 degrees up to 122 F. Okay. Now notice this red box right here. The ideal growth range, though, is 95 to 115 or 35 to 46 C. If you keep that in mind and you realize what are some of the temperatures are in behind the wall, then we're talking about the water that's in the pipe. We're not talking about the water heater so much anymore. It's what's out in that system. Guess what? These are perfect ranges for water temperatures in the lines. One of the ways some of the code officials and some of the people that deal with this are going to try to deal with it is the elevation of the temperature. Okay, it might be periodically, or it might be just elevated. In water behind the walls, $140. What are you going to do with that? Well, that would lead us into talking about different types of tempering valves, mixing valves, and such to protect from scalding. But again, just throwing that out there, one way or another. It could be the maintenance man has gotten too many complaints about not having enough hot water, and he just goes down there and cranks up the aquastat. So some of these things, we have control of. Some of it we don't have so much. Okay. The other one is the velocity. And now some people don't really get that, right? We're talking about the speed at which the fluid is moving through the pipe. That's where we use the term velocity. We are saying that if you run the water too quickly through the lines, that is part of the contributing factor of the problems within the system. Okay, that's causing some of this premature failure on the material. Okay, so you can see here I'm talking about velocities over 2 feet per second. In parentheses, I've got 3, and I'll explain that when we get there. Okay. The other one is the chlorines and chloramines, right? You got to think it from a municipal level. We're getting things added in our water system, right? And that's to help kill the critters and keep them at bay and that sort of thing. But understand that changes the recipe, right? If I have chlorine and chloramines and things like that in my water system, and I have elevated temperatures, and I have high velocities. You see how this perfect storm is. The sun, the moon, the stars start lighting up. And John can sing to you a little bit about Aquarius, but I'm not going to try. But I know he's done that before. But
It
you
is
see
the
where we're
dawning.
going with this, right?
It is the dawning of the age of Aquarius. I will tell you that.
It is. So again, some of these things we just I said four contributing factors. The three of them I've already given you is kind of a no-brainer when it comes to what we're talking about. This is my little pet peeve though, and you'll see where I'm going with this as well. Continuous circulation. That means the people plug the pump in and leave it plugged in. It just spins 24/7. Again, that's a misconcept, right? Or just laziness or not knowing, what the detriment is and stuff. And again, we're trying to, demystify some of this stuff, and so we're going to continue throwing things like that out there. So anyway, continuous circulations, that's a no-no. Okay. So the velocity we have control over, and the continuous circulation we have control of. We don't have control of what's being put in from a municipal standpoint. And if codes all of a sudden elevate the temperature up at higher than 140 or 140, and it doesn't mean if you only run 135 you're exempt, right? So it just means as the temperature's elevated, we have issues. So some of it we have control of, some of it we don't. As mentioned, velocities and continuous circulation. So that's what this little session is going to focus on. Make sure you feel really good about controlling those two aspects. Because as a plumber, as somebody who's doing design work or an engineer, this is what we have control of. Let's focus in on that. Okay. So starting with some conceptual fundamentals about what the dang pump's supposed to be doing in the first place. There's some concepts out there that are a little bit wacky. So what's the job description of a domestic hot water recirculation pump? Okay. What is its responsibility? Okay. And again, people seem to think the damn thing's got to run in order to get hot water out of the faucet. And I'm telling you, I've been surprised at some misconception. So anyway, just understand our goal for this little tiny circulator is to do nothing more than to have the hot water already at the fixture so that when they open the faucet, they're not waiting to try to bring it all the way from the water heater, and they're not waiting for the pump to try to boost it out to the fixture, right? It just means, in essence, that we're trying to keep the hot water lines hot so that when somebody walks up and cracks the faucet, they don't have to wait. They have virtually instant hot water. A lot of that has to do with the design process, the piping in behind the walls and such. But anyway, that's what we're shooting for. Okay, hope everybody gets that concept.
Yeah,
Now,
all too often, Rick, we talk
go
to
ahead.
people that think they think of it as a booster pump.
Yeah,
And the thing is, if the pump wasn't there, the hot water would get to the fixture in ample quantities. All this thing is doing, as you said, is think of it as just keeping that hot water line primed and ready. Really,
yeah,
that's all we're doing. It's
yeah.
shortening time. It's not delivering flow or anything like that.
Yeah, no, it's good to expound on that because again, that's a misconception that's out there for sure. Yeah, and understand that just the pressure differential between whatever's in the water line and atmospheric pressure at the faucet opening is how we get water out of the faucet. Again, believe me, we've had some misconceptions out there. I think the pump is what brings it out, but anyway, I've hammered that home. To go along with that, though, how much does the Recirc pump actually need to produce? How do we come up with that magic number? And this session is supposed to simplify that for you. And I'm reasonably sure we've done this plenty of times, and we have a lot of people saying, you know what, that makes total sense. And yeah, I don't have to do super exaggerated calculations or anything. We're trying to simplify this. There's ways of doing some calculations and so on and so forth. But what we're trying to do is, can we make this simpler and still protect the system and still get the end result done? The end result is, folks, when we open that faucet, we get hot water like now. And ultimately, if you get that done, most people are not going to question anything. But at the same token, we don't want to be ruining the system in the process of that. Okay. So some people look at it as just overcoming the line losses or the heat loss of the primary or the hot portion of the piping going out to the system. Okay. So think of that. We have the hot portion of the system that delivers out to the fixture, and then we have a dedicated return line. That's the second portion or the secondary portion of the system. But if that's all we're doing, that becomes the absolute minimum that you'd want to run that circulator at. Because if you really sharpened your pencil and you got this down right, that means all you're doing is overcoming the continuous line losses of the system. Guess what, folks? That would require the circulator to run 24/7. You see where we're going with that? And we've already pointed out, I've said it's kind of a pet peeve, but it's really not what you need to do within the system. It's one of those contributing factors as far as I'm concerned. Okay. Anyway, what we want to do is we want to satisfy that demand quicker, faster. Okay, so what we're going to do is we're going to run more flow than we need as far as it relates to minimum, but we're always going to watch the maximum so that we're not ruining the system. We're not seeing velocity erosion, corrosion. We're not seeing oxidation due to higher velocities, etc. Okay, so the question is getting this information right, is that important? And of course, we got to say, you betcha. Okay. Any questions so far, Johnny, before we start showing them some details of why we're saying what we're saying? This is third-party stuff. This is not TACO. This is just stuff we pulled out and you can get anywhere.
Right. Yeah, no questions as of yet, but I'm sure they will be coming.
Okay, thanks. So let's look at that number again. Ooh, it kicks out at you several times, that $1.40. Okay, and that's not to say 135 will save your ass, right? So we're saying that as the temperature is elevated, that's part of the contributing factor. Now it says in systems where temperatures routinely exceed 140, lower velocities such as 2 to 3. Now they're giving you a scale there. I wish they would just use one number. That's cool. We can live with it. It actually gives you some flexibility in writing of what you could do. And I'll show you where we've given you a nice little handout that brings that to bear. You'll see us use that at times. So anyway, that's velocity and temperature. They're saying, hey, when the temperature's being raised, be careful, keep those velocities down. In a nutshell, right? The other thing is these locally aggressive water conditions. And some people have thought that that was like hard water. I've got hard water. I've got, 10, 15, 20 grains. And that's what's, that's eating my pipes up. Well, no, not just the hard water. It has to do with velocity. But what I want to point out is I believe what the Copper Development Association was talking about. You can see that where this comes from, the Copper Tube Handbook, and it's page 11. And what they're getting at here is this locally aggressive water condition has to do with one of those contributing factors. Which one do you think it is? Which was one that we didn't have control of? Right? The chloramines and chlorines and things that we add into the water that make it more aggressive. Okay. Again, for the sake of time, you guys can type stuff in, and John will give me some feedback as it's coming. Again, in my particular screen, I can't see your folks' comments. But here's another thing. I'll just real quickly say, hey, we're talking about domestic hot water here. We're not talking about closed loop hydronic heating systems or cooling systems. That's not why they wrote this get out of jail free card. John, what is the get out of jail free card in our world?
In our world, a get out of jail free card?
Yeah, as it relates to what we're talking about here from a manufacturer's perspective.
Oh, that's just a weasel clause based on what we know here. Yeah, it's the ultimate weasel clause.
Yeah, very good. Okay, so both the supply and return piping should be looked into. Be careful on both of them. But what I want you to get out of this portion is, hey, the problem normally is in the dedicated or common return side of the piping system, because guess what? That's where they neck it down, right? That's when they neck it down to 3/4 or 1/2 inch or or something like that. And that's when the velocity increases. Think about the old Venturi effect, right? The velocity is going to increase during those times. So just be careful. Most of the failures that we know of happen in the dedicated or common return portion of the system. So just beware of that, okay? Lastly, I'll go ahead and read this to you. Care should be taken to ensure that the circulating pump is not oversized and that the return piping is not undersized. Both are common occurrences in installed piping systems. That's their get out of jail free card. Don't come back to the Copper Development Association and say, hey, your pipes are defective because I've got a sprinkler system going on here, right? So understand that's what we're talking about. So let's put a number to it. Again, this is part of your class handouts. I've got a little thing I've made up just as a quick reference is all it is, okay? And again, we got let's say we're using type M copper. Let's put a number to it, right? Excuse me. So here's 3/8 through 3 inch. Here's your 2 feet per second column, and there's your 3 feet per second. The only reason there's 2 columns here is because of the variable they gave you from 2 to 3 feet. Now, what you want to understand, we're talking GPM, and we're talking about these 2 columns being under the column that's recirc portion. This is your dedicated or your common return portion of the system. You know, a lot of times the hot water going out to the system's not that big a deal. They'll let you go to 5 feet per second. And cold water, again, not that big a deal. They'll let you go to 8 feet per second. We are talking about a specific portion of the system here. Okay, everybody good? All right.
Yeah, we got Michael Knapp actually got a question about the return pipe is commonly installed before you put the pump in, or if there's an existing house and you want to add recirc, the return size is out of their control, or any existing
Oh,
building for that
absolutely.
matter. Yeah, it
Absolutely.
is absolutely at your control. And if that's what you have, that's what you've got to size the pump to, is the
Exactly.
limitations on that 1/2 inch pipe.
Yep.
Absolutely, yeah.
Good point. Bring that up because that's what we're trying to hammer home, folks. Appreciate that comment. So again, I'm not picking on the copper folks. Let's look at the good old PEX folks. This is right out of one of the major PEX manufacturers here in North America, and this is out of their design book for the plumbing industry. And as you can see, they have no problem with you going 10 feet per second, right? Under the cold water side, they have no problem with you going up to 8 feet per second during the delivery of domestic hot water. In fact, all the way up to 200 degrees, right? What I want to point out here is the domestic hot water return portion, the same thing I called the common or the dedicated return lines, right? They're saying right here, you better keep that at 2 feet per second, folks. They're not giving you that variance. They don't want it to exceed 2 feet per second. Okay, there's that number again. Okay, that it's not really a magic number. It's not like a magic bus. Okay, but to understand 140 degrees, there's issues, and approaching that somewhere in and around. Okay, really all this particular manufacturer did is kind of pull their information out of the ASPE Plumbing Engineering Design Handbook, Volume 2, Plumbing System. So let's put a number to the PEX side of things as well and take a peek at that same handout. Okay, so PEX in STR9, that's your standard dimension ratio. There's 3/8 through 3 inch in some cases, right? So here's your 2 feet per second column. Let's throw a number at it. If we got 3/4 inch dedicated return line, folks, we better keep that at 2 gallons a minute. Okay. So again, how are you going to control that? Well, we're going to get to that a little bit as we move into this. John, what do we always say at TACO?
Do the math, Cupcake. Do the math.
Yeah,
It's an
cupcake.
important thing. The math
We're
will
not going
never lie to you, people.
to. We always have to pull our pencils out and our pieces of paper and our calculators and do some kind of math. Okay. Again, there's all kinds of software out there. I'm going to show you some as well. But we want the concept to be ingrained in your brain. And one way of doing that is to do it longhand. And that's what this worksheet I'm showing you right here. This is I put this together several years ago just to, I'm the kind of person when somebody calls me and says, hey, I need help doing this, one of our reps will call us or something. I said, well, let me give you this. You just fill this out and I'll be glad to help you. But all it is like how many questions am I about to forget? And so that's why I love forums. They help me not to forget things. So anyway, you've got a copy of this worksheet. I'm not going to go through the whole thing right now, but most of it's self-explanatory. But what you could do is you could get a hold of one of us, get a hold of your local rep. All of our reps have sat through this presentation. They can walk you through this. But if you want help and you want to do it right, you need to have these fundamentals down. And this worksheet, this manual worksheet, will help you grasp what we're talking about. So that's part of your handout as well. Now, our little system example that we're going to use tonight by walking you through the actual app is going to be this. It's just simple. We're showing a tank type water heater, right? We're coming out. We've got a tempering valve or a mixing valve here. We're coming out with some 1 inch and 1 inch and 1 inch. We neck it down to 3/4 here, but notice off the 1 inch we're picking up some a full bath, a 3/4 bath, a kitchen and bar, a double bath over here. Notice how we went to 3/4, 3/4, 3/4, and this last little piece, a 1/2 inch, to pick up this little this last fixture group. And then from the last fixture, in this case, we've got a dedicated return line that's coming all the way back at 130 foot, and it just happens to be 1/2 inch. We're not telling you to make it 1/2 inch. This is would be an example of a system that's already out there. We know most of the people watching this will often get opportunity to do service work or change out work or something along those lines. You're not all doing new construction. I will say this, just to give you a wink and a hint, the days of running 1/2 inch dedicated return lines, folks, should be gone based on the information you're getting from this session. Okay. Again, you neck that pipe down that small, that's gonna be a big limiting factor, as John mentioned, based on the question that was asked. I believe that was by Michael. But anyway, just a heads up on what we're going to use here. So I would like to introduce to you the DHW, that's Domestic Hot Water Recirc Size Right Circulator Sizing Tool. Okay, I'm going to switch gears a little bit here. I'll show you what it looks like, but I'm going to go ahead and bring it up just like I normally would. This can be found on our TACO page, right? We can go in there and bring something up like this. There's our TACO Comfort under my saved favorites, right? I go into my selection tools right here. I click on that. I go over here to the DHWR Size Right Circulator Sizing Tool, and I click on it, and behold, here it is. So any questions? Any before I jump right into this? Anybody want to cover something?
No questions. Jim Hedden had a comment. A real problem is with a common 1/2 inch recirc line with multiple tappings for recirc to several bathrooms. All connections are hard to get to and just teed in without any balancing valves. Now
Oh
there's a
yeah,
diluted blend supply of DHW to those far fixtures. That's
yeah.
kind of that's a goofy piping arrangement right there.
Yeah, that's a design problem, and
Yeah,
you are right. We call that a balancing act. I heard that used in our industry a long time ago when it comes to actually balancing on manifolds and stuff. Well, we get into domestic hot water, we got the same problem. You know,
right.
we're trying to get the water to go. It wants to go the path of least resistance, and you got to kind of give it some pointing signs, and we call those balancing valves and check valves and things like
Mm,
that. So
yeah, okay, that's yeah, definitely a kind of a goofy plumbing layout right there.
yeah.
All right, let's see what this bad boy can do.
All right, let's go for it. So the first question is going to ask you is, well, I'll show you the description. You guys can read that on your own time. Okay, so it's just what we're doing, why we're doing it, etc. It expounds on why we're having this session tonight. Okay, so is there an existing or will there be a domestic hot water recirculation line installed? That's either a yes or no, folks. And tonight on our example, we had one. So boom. Now you got to understand, as we put these little radio dials or radio dots or whatever they're called, as we click on those, that actually changes things in the background. So you might get something to populate a little bit different. So heads up on that. So when we have a dedicated return line, we're going to say yes. Okay. Then the water heater type, what's our choices? Just click on this. We either have a tank style. We don't care if it's indirect or electric or gas fired. It's a big tank, right? And we need to know that. So Or it's a good old tankless, and these are more and more popular nowadays. Or it could be a simple little sidearm coil or a internal tankless coil in an oil-fired boiler. That's normally for the folks in the Northeast that still have those to deal with. But anyway, tonight on our sample, as I showed you, was a tank style. So I'm going to click on that. Now, here's one to get your arms around a little bit. When you have a tank style, you're either going to have a trunk and branch with recirculation, or you're going to have this thing called a full-size loop. I won't get into that, but real quickly, I'll just show you the piping example. We'll give you a picture of what we're talking about. So you can just click on that to verify what we mean by our description. Okay, so trunk and branch with Recirc, you understand that. Now notice you've got supply pipe material and return pipe material. Why would we give you a choice for both? Well, we did that because as soon as we came up with this thing, somebody said, you know what? There's a bunch of systems out there that had initially copper, but when we actually upgraded and ran the dedicated return line, we ran that in PEX, some kind of flexible piping system, right? So when we did that, we said, hey, let's just break it up because potentially they're not always the same. This little button here, I'm going to go ahead and click that. That's just the people that like to see the details. One of the people that were weighing in on this thing said, there's people that don't care, and so get rid of that. And I said, well, we're not going to get rid of it, but we can hide it for you. So anyway, I like to see the details. I'm kind of a detail-oriented kind of guy. In fact, John gives me some crap on that quite a bit, and that's okay.
Credit. It's credit. I give you credit for that. Credit.
No. Anyway, I know when it comes across a certain way what he means by it. So I'm trying to find my way to balance that whole thing out. Okay. So let's do this real quick, and I'm going to do it quick. Don't worry about me going too fast. I want to first show you this sizing tool is really fast once you get used to it, but I'll explain what I'm doing here. First thing I'm going to do is start on the supply side. I'm going to put in that first segment of pipe. I don't expect you to remember this unless you've printed it out already, but coming out of that tank style water heater, we go right into a tempering valve, and out of that tempering valve, we have 1-inch piece of pipe, and then we continue with some 1-inch pipe, and those two numbers together is 30 foot and 20 foot together. What is that of 1 inch? We have 50 feet. So I just simply put 50 in there, and I'm hitting my tab button. You folks that want to hit the enter button, you can use that as well. But folks that deal with this stuff all the time are used to using the tab button, the upper left hand. So I'm going to put a little 3/4 inch pipe in there, right? And I look at those numbers. I had 40 plus 20 plus 10 together. That is 70. So we're going to go 70, hit my tab button. And there's a last little section, is a little bit of 1/2 inch that's going to feed that last little fixture group, and that's only 10 foot. Now I just entered the supply portion. Notice the supply portion of that, right? Notice, it's not giving me anything over here. Now, real quickly, folks, for the sake of time, tell me why I don't have any population on my pressure drop in feet of head. Why don't I have anything yet?
I know, but I can't answer.
Come on, how many
J-
people we got on there, John? Because I can't see it.
again, 62.
Okay, 62
I've
is
got a
good.
couple here. We got James Zampano says no flow. Kevin Murphy
Ah,
says no height. Jim Hedden says,
no.
don't you need to put in fittings and valves? No flow rate, says Douglas. GPM
Ah,
says Zoo. So yeah, I think no flow, right?
yeah, no flow, baby.
No
Okay,
flow yet.
this is what we're doing to try to simplify this for you, right? We're going to go to the return line. Remember when I said most of the problems are in domestic hot water recirc systems? They're not on the supply side because of the lower velocities. Is the nature of using, pipes that are based on code restrictions and stuff. Typically, we're not dealing with high velocities there, right? We're dealing with it on the dedicated return line. So let me show you what we did for you to make your job a lot easier. What size was our dedicated return line in that existing example that I gave you? It was 1/2 inch. Okay, watch what happens when I kick this over there and I put in that 130 foot. Boom. Now everything starts populating based on the flow. What's the flow based on? What do you suppose that number is, folks? Okay, it says this line has a maximum flow limitation of 1.6 gallons per minute. Guess what that is? In copper, that is either 2 or 3 feet per second. I know that based on what we said for conservative point, it's 2 feet per second in a piece of half-inch type M copper. Okay, so now we have the numbers. Notice these two numbers here and here added together equal this number in feet of head. But wait, we're not done yet.
But
Some
wait,
of
there's
you,
more.
yeah, some of you noticed that there was valves and fittings. Yes, we do have to account for that. And we're going to do that. There's a couple different ways you can do it, but the easiest way, because most people don't know, right, that equivalencies and that sort of thing, is a lot of people in our industry just use a valve and fitting factor. As a default, we're going to give you 40% of whatever that is. We're going to actually bring that over. So 40% is 6.85 is 2.74, and we're just going to carry it over there. You know what? Since I feel a little more comfortable about what that number really is, I'm not going to be so conservative. I'm going to be a little more liberal. I'm going to know for a fact that it's going to be somewhat less than that, right? Again, here's the thing about a valve and fitting factor. It's kind of a wag, and you folks know what a wag is, right? There's no scientific data behind it whatsoever. In fact, even if we were using the equivalency charts, those go back to the late 1800s. Let me say that again. The technology and the data go way back to either the late 1800s or the early 1900s as far as where those equivalencies come from. And of course, the variable between all those equivalency charts is that what flow are you using? Is that maxed out flow, or is that half the flow? Is that a minimum flow? So again, it's just a wag. So again, I'm going to put 25 in there because I feel a little more comfortable, and you folks can make that anything you feel comfortable with as well. Now, on my drawing, did you see a little mixing valve? I believe we did, right? I'm going to have ability to override that. I can put that CV value, that's our flow coefficient, okay, of that particular mixing valve. And whatever one you're using, you can put it, you can override this to anything you want. So now you've got the number here added to this number here, added to this number here. That is cumulative based on our design. It's all in series. So I've got 10.4 feet of head, which carries right over here, folks. I already know what my pump size needs to be. Again, I'm not running the minimum. I haven't even looked at my heat loss calculation right now. Okay, there's some assumptions there that I'll have you look why we made those assumptions down here. You can read that on your own time. But I got a pump at 1.6 at 10.4 feet of head. That's pretty simple. We have a couple other newer drop downs. John, have you seen these already? I got circulator efficiency type. Do I want the high efficiency? Heck yes. Okay, I'm not selling standard efficiency stuff anymore. So that's just me. You can do whatever you want, and that just helps you dial that in a little bit closer. And then connection type, okay, because you got to realize Taco's got the universal flange, which has either the standard or reversed uh, 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 uh,
Is
flange
rotating.
configuration, or I've got the little half union that has like a 1-inch BSP half union connection. So we got some sweat connections, blah blah blah. So I'm just going to ask it for any of these. I'll take anything, but again, this helps you narrow it down a little bit more. I'm going to click search. Hey, look at here. Okay, it gives me a nice package here. It's called our Smart Plus E package. Okay, and I believe that's part of your handouts tonight. So what do I do with this? Well, I'm gonna print this out as a submittal, or I want to get a good look or a good. I get to look at it anyway, but I actually want to print it out later for my job file. So I get to populate the product tag, Domestic Hot Water Recirc #1. I get to go down here and say, oh, that job's called the Alpha Building. What engineer designed this? What contractor is installing it? And you know what is the rep that if he's doing it, he's going to put his name in there as well. We simply come here to create the PDF, and let's show you what we came up with. First thing that's going to populate is a submittal data information, which is great. It's specifically for the Smart Plus E. It's all filled in for you, folks. All this information of who it is, what it is, who it's for, all that good stuff. Gives you all the specifications, give you materials of construction, gives you orientation, gives you flange dimension, all that good stuff. In this case, it has some other items that come along with the package to give you some stuff on here. But here's what I love about it. It actually gives you a copy, a printout of the worksheet that has the information that you just went in and grabbed. It tells you everything you want to know about the system as you've designed it. Okay. And it spits out at the bottom, it tells you exactly that, how much gallons you have in there. It did that calculation for you and tells you everything you need to know right here. I need a pump at 1.6 at 10.4. Pretty handy. And it also gives you the actual design, okay, on our circulator performance curve. So there's our flow. Come up here. Of course, this is sideways. You would take this and turn it to a landscape position, but it tells you right where your operating point will be, and it lets you know within this circulator, I'm right where I need to be, and it actually gives you a good way of actually setting it up. You go to the high setting on the dial, and you go just slightly up from that, you're good. Remember, the 1.6 was nothing more than the maximum flow that you would need through that line. You can dial it back a little bit with no problems, okay? So anyway, I just wanted you to see that and understand what we were doing there, okay? Hopefully
Yeah,
that makes sense to you all.
yeah,
Any questions on that?
not as yet, but just make sure, guys, 1.6 is not a target, it is a maximum. I mean, you could
Maximum.
conceivably, that thing could actually be cranked down to 1.5, 1.2, 1, it depends on the heat loss of the line.
And John, tell them what happens with the head calculation when we ever so slightly pull that GPM back a little.
Oh yeah, when you drop the flow, you will dramatically drop the head.
Yeah. See?
Because head pressure or head loss, friction loss will go up exponentially
Yep.
based upon the increase of the flow. So
Very good.
if you double the flow, the head loss might go up 3 or 4 times, or
Yeah.
the square of the square, basically.
Yeah. So you have the ability, what John's talking about, we have the ability to override that and pull that down to whatever we want. Okay.
Yeah,
That's just a start,
hit
right?
it, bring it down to 1, just so the guys see what happens.
Okay. 1.0. Boom. Look at that. Okay. I'm down to 4.6.
Yeah.
Okay.
The
That's
pump
good.
doesn't need to be big. The pump does not need to be big.
No, these are little pumps, folks.
Yeah.
And the good thing about Takeo is we got little pumps and we got dials on there that do a really good job for getting it back down where you need it. Okay.
But Douglas asked, what about changing the return line to 3/4 inch? Well,
Oh,
we
that
could
would
change.
that would do that, but for the sake of time, we're not going to go through that right now. We want to point you at takeocomfort.com and have you go play with it and see what it does. Okay.
Yeah. Yeah, you
Real
you
quickly,
you
I'm
could
going to
you
go
could
ahead
go
and
up to 2.2 gallons a minute, and the head would drop way the heck down.
yeah, yeah,
Yeah.
yeah.
All
So
right.
John, what do we
Yeah.
got here?
Hey, it's Takeo trivia time. We usually do it a little bit earlier, but I want to give you guys the opportunity to have our Takeo trivia, and I think that the prize tonight is going to be that Takeo Smart Plus E package, circulator with the smart plug control. All right, pretty cool,
Nice,
huh?
nice.
Pretty cool. So if you want a chance to win that, now's the time. And the Takeo trivia question has to do with Butch and Sundance. Rick, would you hit your little key there? All right. In Butch Cassidy and the Sundance Kid, the part of Harvey Logan, who famously challenged Butch to a knife fight, and it didn't work out well for old Harvey, was played by the 6'9" actor Ted Cassidy. Now, hit it again. What other iconic role is Ted Cassidy best known for? What other iconic role is Ted Cassidy best known for? Type your answer into your question chat section, and I'll make a note of everybody who got it correct, and we will go from there.
Right on.
All righty. So type it in, guys. Got a couple of
All right.
answers here. Very good. Very good. Rick, take it away.
All right. Well, folks, we're just showing you the plethora of ECM offering that Takeo has right now. Okay, we just want to make sure you kind of get the concept of, we're still calling it from 3 to 300 gallons per minute in ECM technology, and we've got some new stuff. We're not going to show you this tonight, but what we're gonna show you just in this one slide is we got lots of choices. You folks, you realize that now we have the stainless steel versions of the 007, the 0015 E3, and the 0018Es. Those are all available in stainless steel in both the BSP half union configuration as well as the universal stainless steel flange. So again, we're growing in leaps and bounds by having stuff for you. We got these big pumps. I mean, we go all the way up to 3-inch in stainless product now. So just keep that in mind. We're growing this thing. That doesn't give you a license to oversize your pump just because we have big pumps, right? We want to just be able to accommodate those larger applications where we need big pumps. Okay. Let's look at the smart plug. Okay. The first thing I'll show you with this thing is the good old Birdman. I miss old Doug, don't you, Johnny? I
I
miss the
do. I really do.
and his replacement is great as well. But you start building a relationship with people, and Doug Bird was the product manager when we released this product, right? And he's standing there as a proud papa. We actually had best of show in 2017 with the smart plug. Just a little pat on our own back there. So what is it? Well, basically, it's a plug that you could plug any pump into, okay? Any 120 volt pump, as long as it's under 6 amps, right? It has a couple different ways that it operates in the smart mode or the pulse mode, and we'll get into that a little bit, show you what that's all about. It just simply brings the circulator on for 5 minutes and shuts it off for 10. It's all about one of my pet peeves, right? Don't let the pump sit there and spin, and don't worry about trying to figure out what your adjustable timer is. Okay, this has some brains in it. We're going to show that to you as I move along there. Okay. So, smart solutions from a smart company, okay? We do it by anticipation. We're anticipating what the occupant's going to do within their structure, right? When are they not using hot water and when do they want it? Let's be smart enough to bring that on, anticipate it, and have it there when they open the faucet, they've got hot water. We do that by learning how their usage patterns are, and we adapt to their use, okay? We don't have to program anything like we would a timer, right? We don't need to remember anything like the time change that happens twice a year in most states. Okay, I don't think it happens in Hawaii. I don't think it happens in Arizona, and there might be somewhere in the East Coast. But okay, there's only 2 or 3 states that don't do the time change. But anyway, I could give you my opinion on that. I just soon not, but I'm not a farmer. So how does it work? How do we know how to do this? Well, we do it by pulsing. We're going to pulse, excuse me, regardless of if we're in the pulse mode or if we're in the smart mode. The way this thing works is by pulsing. We will not run your pump more than it needs to run, in other words, right? So we're going to run it 5 minutes on, we're going to shut it off for 10 minutes. We're going to do that for 7 days, and we're going to record what happens during those 7 days, right? We're going to measure by a sensor on the supply line out, not the return line, on the supply line out. We'll show you some pictures of that, and we will get that nailed down. We'll know what it is. We record what the occupant usage pattern is, and we do that for 1 week. And then after we know what their usage patterns are, we go and repeat that. Okay. We just change for whatever day they do for these 7, right? We just repeat that, and it's a continuous learning process. Okay. It's dynamic. It learns as they change their schedule. This thing learns as well. Here's a quick example. Let's say they're taking showers at 6 a.m. on Monday. This will be a weekly thing, but on that next Monday, there's these things called these 2-hour windows. Okay, so at 5 a.m. it starts pulsing. It does not run continuously. It starts pulsing, and it goes beyond the 6 a.m. when they normally need it, out 1 hour. So 1 hour prior, 1 hour past, but it doesn't sit there and run for 2 hours. It just pulses. Because what did we say our job was? To make sure the water is already there. We just want to make sure when they jump in the shower, they don't have to wait. And then when they're done, the damn thing shuts off for you. Okay. It'll do that over and over again. It'll wash, rinse, and repeat. Okay, this is handy. Again, this kind of gives you a little bit of idea than this conceptual sketch of what we would do here. Remember, the sensor goes on the supply. We need to monitor when they're using hot water. We don't care about it coming back. Okay, we care about when they're using it. What we do is we look for a little bit of a little bit of temperature rise on that dedicated return line for a short period of time. And we call that part of the usage pattern. Why do we call it an event, right? So an event is a small a tick up in the temperature on the supply line for a short period of time. Now, that's not real short. We don't record when somebody rinses a dish or just a real quick wash of the hands or something. We want to know when they're taking showers. We want to know when they're jumping in the bathtub. We want to know when they're running a load of laundry, a load of dishes, etc. Okay, so that sensor on the outlet does that for us. Out of the box, we go with a smart mode. Okay, so we learn those usage patterns, right? But I'll tell you what we could do. In some cases, we need to do this, and I'll bring that up in just a second. One thing that is always a hassle with a timer is to remember to change it in and out of the vacation mode. I'm sorry. The what do we call it, John?
Learning mode.
No. Go back to when we changed the clock.
Daylight
Daylight savings
savings.
time.
Yeah,
There we go.
daylight savings. There you go.
So daylight savings time is one thing. That's what you used to always have to remember. With this, you won't ever have to worry about that because the 1 hour window prior, 1 hour window after, it's just going to take care of it the majority of the time. And then as it sees the time change on the usage pattern, it fixes that automatically as well. So when you go on vacation, the other thing that people would have to remember is to unplug the thing, or unplug it or shut it off, and then remember to plug it back in, etc. Guess what? When it doesn't see any usage for 36 hours, it goes off automatically on its own and doesn't come back on until it sees you using hot water again. Kind of handy, a lot smarter than what we've been doing for the last 30 years, wouldn't you say? Okay. The only thing it does while you're on vacation is once a week, it'll come on for 10 seconds just to give you some exercise, just to make sure nothing locks up while you're gone, etc. So, and again, when you don't have a predictable schedule, we can go in there and just push the button and change the mode from smart to pulse. And folks, that's what we tell people to do on commercial applications, or in those people that have their occupations are either nurses or doctors, or they're just not going to have a schedule, maybe airplane pilots and things like that. Guess what? If you don't know what your schedule is going to be, the safest way to do this is just set it up on pulse and let it come on. Okay, it's only going to come on for real short periods of time, 4 times an hour. It's going to make sure those lines are nice and hot for you. Here's a little sketch that kind of gives you an idea of what that would look like from a mechanical standpoint. Remember, picture's worth 1,000 words here. A couple different orientations there where you could pipe it from the top or pipe it from the bottom if the code allows you to. Okay. Either way is acceptable as far as we're concerned. You have to check with your local codes to make sure that's applicable in your area. Okay.
Yeah. Another good use for pulse mode.
Yeah.
All the people who work from home now and are going to be working from home for the foreseeable
Very good,
future,
John.
or permanently, because a lot of us aren't going back to the office. You don't really have a regular schedule, do you, for that sort of thing? And
That's
if you
right.
have that thing doing in the pulse mode, 5 on, 10 off, that's going to be 20 minutes out of every hour. You're going to be primed. The hot water line will be primed and ready,
Yeah.
locked and loaded, as they say.
Well, so John, the Smart Plus E is the giveaway for tonight. Did I hear that correctly?
I believe it is. Yes, I believe it is.
Okay,
Dave is
very
the
good.
keeper of these things, but I'm going to go out on a limb and say it's the Smart Plus E. If it isn't, it's going to be the Hot Link Plus E, which is kind of the same thing, only different.
Well, I'm going to show you that next.
There you go.
Okay. All we're saying is now we have this 006 E3 that I showed you the performance curve of. We got it right here. That we package it with a cord and a Smart Plus E and a nice little box that's got all kinds of good information. And we do the best packaging in the industry compared to everybody else. Again, we We hold that title as well. Okay.
I do
Next
have,
one
before
is
we get to, before we get to the hot link, there was one question about the smart plug. What type of usage triggers an event?
well, remember, there's a sensor up on the supply portion of the hot water line going out to the fixtures right next to the water heater. I always like to say it this way. Right before that pipe goes into the wall next to the escutcheon, you're going to you're going to strap that thermistor on there. That's where it's recording those usage patterns. Hopefully that answers the question.
Yeah. And in terms of what exactly it's looking for, it's kind of a fluid thing, but pardon the pun. But
Yeah.
really, what we're looking for is a temperature rise, a sustained use, and then a temperature drop. Again, a shower, washing dishes, that sort of thing. If you turn, if you run the hot water to warm up your razor or shaving, that kind of thing, that might do it too. A quick wash of the hands, it's probably not going to pick that up because that's kind of a sporadic thing,
Yeah.
as to log it as an event. Now, again, people working at home and we got to wash our hands a lot. That's the pulse mode's forte.
Yeah. Yeah.
Yeah.
Good point.
So I hope that answers your question there, Douglas.
So the hot link is something we came out with probably now about 8 years ago, I would imagine. But that's our answer to a crossover valve. That's a generic term of what this thing does. We're crossing over from hot to cold. Better said, we're temporarily using the cold water line as a return line because guess what? This is kind of a band-aid or an afterthought. Okay, we didn't put in the dedicated return line like we were supposed to, so therefore we've got to do something else. So, but this works really well. This has a good track record. It's done a really good job of allowing the hot water to be pushed into the cold water side to bring it up to the fixture. Then it shuts off. It has a little bimetal disc. I'm going to show you a picture of that in just a second. But it has a little disc that as soon as it detects the warm water is at the fixture unit, it go ahead and it closes off. We're not going to fill the line with really hot water like some of our competitors have been accused of. Okay. So anyway, we don't have to worry about deadheading. We're dealing with little tiny pumps that have basically open impellers that don't pump a lot of pressure, etc. So we're not really worried about that. It works really good. We've had some great track history. Here's that cutaway I was going to tell you that shows that this is your little bimetal disc. What happens is the water actually comes through a screen like an aerator screen here, comes down into this cartridge. This actual disc has a hole or a couple holes in it, depending probably on which one we have. And it moves through there. It comes down through this little hole here, moves up past this check valve and down into the cold side of it. But as soon as it detects the tepid water actually starting to get warm, and it's somewhere around 100 degrees, it's slightly over 100 degrees, then all of a sudden it changes position. It's a thermal snap disc, and it snaps down on top of this O-ring and then stops the flow right here. It's no longer coming this direction. It's nice and hot right here. So when they open the hot water faucet, we pull straight up and out of there, and we are happy. Again, this is a Band-Aid. This is an afterthought, but it's a good way to fix some problems that are out there. I wouldn't design a system around these. It doesn't really make sense, but it could be done. So anyway, my 2 cents worth. That same thing I've already said. This cartridge actually, one thing that we say about ours that's a little bit different than our competitors is we don't have to take the whole assembly out. We just simply reach down here with our hand and we unscrew this thing. We can pull this cartridge out and actually clean it in place. So this valve stays in place. We pull the cartridge out, take it up with some white vinegar and water mixture and a toothbrush and kind of clean it up and clean up this aerator thing. So we could do some service with this without having to just throw something away and put something new in there. So pretty handy. Again, we got about probably 7 or 8 years of track history with this thing now, and it's done quite well. Okay, we could do multiples. Okay, we've done apartment buildings where they forgot to recirc from the top floor. We just go in and put these things in there, and it does a good job as well. Again, they shut off as soon as they get warm, so that leaves the additional flow to go to the next fixture We don't have to worry about balancing or anything like that. Don't overthink this. Okay. And it also comes in a kit, right? We put the hot link, we put the 006E3 and the smart plug all together in one nice little package, and we call it the Hot Link Plus E. Okay. And it shows us a typical picture like I did before. Again, if you folks want copies of these little sketches that we put together, we can get those to you. Just let us know on the email, and we'll do that for you. But I'll turn it back over to John here, and he can take it away with that.
All righty, very good. Very good. Thank you. And I'm the presenter now, right?
I think I'm off. Yep.
All right, oops, and I'm gonna, let's see, show, am I the presenter? Yes, I am the presenter. Show my screen. All right, what
Perfect.
are you guys looking at? You're looking at a big old mess here, aren't you? Here we go. All right. So again, I want to answer the Takeo trivia, then we're going to get to a couple of questions that are here for you. Okay. Then I need to put my webcam on so you can see my handsome mug. Again, let's get the trivia question done. Ted Cassidy played Harvey Logan and challenged Butch to a knife fight. What was Ted Cassidy's other iconic role? A lot of you said Jaws from the James Bond movies. That was Richard Kiel. That was a different dude. That was a different humongous dude. Okay. Ted Cassidy played the other humongous dude, and a lot of you got it right. That was Lurch. He played the butler
Lurch.
Lurch
I
on the
love him.
Addams Family. All right. So a lot of you guys got that right as well, and we put you into our spinning wheel to see who's going to win. So we've got a bunch of T-shirts to give away, and we're going to also give away the either the Hot Link Plus E or the Smart Link or the Smart Plus E. Not sure which one yet, but you'll get one of them. Okay, and if you get the Hot Link Plus E and you only want to use it as the the Smart Plus, you can. You just don't have to put in the crossover valve. It's the Hotlink Plus E is the Smart Plus package with the crossover valve and hoses for an undersink in an undersink installation. There we go. Yes, and Richard wanted me to put. Don't forget, where's Eric? Where's Eric's for the T-shirt? So I've got those. I've got a bunch of you guys ready for that there.
Yeah.
Um, I had a question from Paul DeLost about will this work on a tankless heater? Boy, I'm telling you, Recirc with tankless. A lot of people do it wrong, and a lot of people do it badly. First off, the crossover valve won't work with a tankless. Ours won't because the flow rate through it is not enough to trigger the water heater. All right, and one of the things you want to do with Recirc with a tankless is you want to trigger the water heater. That's the whole point of a tankless. You're
Yep.
not storing a bunch of hot water. So whatever flow rate goes through that has to trigger the water heater. Ours doesn't do it. Doesn't have quite enough. Now, there are other people that say some of the others do have some of the others say you can use them with an indirect, but we've tested them and they have the same flow rate as ours. How they can go ahead and say that you can do it, I don't really know, but that's just the way it is. So with ours, no. And the other thing about someone also asked about the smart plug being used with a tankless, and again, not anything that works on time is really a bad choice for your tankless coil for your tankless water heaters because you really don't want that water heater banging on and off, which it will if you have water running through it, but nobody's using any hot water.
Yeah.
Okay, you don't want that thing to fire when no one's calling for hot water because you'll basically short cycle it into an early grave
Yep.
very closely, very quickly. So the typical type of domestic hot water recirc that is recommended for tankless water heaters is an on-demand type of system where you have a push button, whether it's a wired push button, a wireless push button, or a motion sensor that can enable the domestic hot water recirculating pump uh, when a call for domestic hot water is imminent. All right, so consider a push button. Okay, you go in, you're getting ready to go take a shower. All right, there's a button mounted somewhere in the bathroom. You hit the button, that turns on the pump. All right, and in this case, a big pump and a powerful pump, a high head pump is actually a good thing.
Yeah.
We use the Takeo Genie, which is a 008 or even a 0011, depending upon the size of the house. You turn that pump on, bam, that pump comes on right away. Bam, it's getting water right through that hot water line as fast as it can, and its job is to evacuate that hot water line of cold or tepid water as quickly as it possibly can. There's a sensor integral to the circulator that will shut the pump off the minute it senses either a 5 or a 10-degree temperature rise, and that's adjustable. Once it's there, you get in, you turn the shower on, you're ready to go. So you hit the button. By the time you have your bathrobe off and hung up on the hook, the hot water is going to be there. That's how quickly it's supposed to work. So that's how you would, that's the recommendation we'd have for a tankless type of water heater. Now, Eugene Vick said, would a buffer tank added to a tankless accomplish the same thing? And then we could use a smart plug? Absolutely. At that
Yep.
point, you're going to be taking water out of the tank. Kind of defeats the purpose of a tankless, okay? Because the whole point of having a tankless is so you don't have a tank and you're not keeping a whole bunch of water stored at a certain temperature. But it's an excellent way of going about it, because then you recirc through the tank, you don't make that water heater fire unnecessarily, and then when you're ready to when you need the hot water, it's there. So that is a good solution. It's kind of taking a left turn away from what the benefit of a tankless, but if that's what you need to do, that's definitely what you need to do. Okay. Cool. Excellent. All right, shall we give some stuff away?
Yeah.
All right, let's give some stuff away. All right, here's the first. Here's the first one, for the random picker wheel. This is for the t-shirts. All right, I got a bunch of t-shirts that I'm going to give away. I'm going to give away 5 t-shirts. 5 t-shirts, people. 5 t-shirts. I'm writing that down. I'm going to click on the wheel. You can only win once, okay? You can only win once. If your name comes up 3 times, you're not winning 3 t-shirts. All right, so let's check it out. Who's going to win the first t-shirt? Chun Lee. Chun, excellent. All right, what we're going to do for the winners is we will email you tomorrow to get a shipping address or mailing address and t-shirt size, or you could put it into the chat question section. It's private, so only we'll see it. So you can do that if you would prefer. Otherwise, we'll email you tomorrow. So congratulations, Chun. All right, now who's next? Paul DeLost. Congratulations. I believe you've won a t-shirt before, Paul, haven't you? I think
he's got them hanging up in his.
He's got a wardrobe, all right. You got to take after dark wardrobe, all right. So okay, there's 2. All right, who's next? Joe Jackson.
Joe Jackson.
Joe Jackson. Now, is this the look sharp? Is she going out with him, Joe Jackson, or is this shoeless Joe Jackson? I'm not sure which one.
Well, he'll tell you right now. Stepping
Let
out,
me know,
Joe Jackson.
Stepping out, Joe Jackson. Atta baby.
Yeah,
All right, there we go.
I think I know Joe Jackson.
You do?
I
The
think
Joe
he's
Jackson or that Joe Jackson?
My state.
Ah, there you go. All right, Todd Herzog. Todd Herzog gets a t-shirt.
Hey, Todd.
Congratulations, Todd. Or are you Bo Jackson's cousin? That's Eugene Vick. Okay. And last t-shirt. Last t-shirt's going to go to Ted Clevel.
Right
Congratulations,
on.
Ted. So I got 5 winners for 5 t-shirts. Excellent. Congratulations, guys. All righty. Now we're going to go to the big dog. This is for the Recirc pump. Now, again, I'm not sure. I don't know whether we've got a Smart Plus or the Hotlink Plus E. It's going to be one of the 2. So you will be cool with this. All right. So these are all the winners who got Ted Cassidy played Lurch. Ted Cassidy played Lurch. Let's see who is the winner. It looks like all right, Steve Hodgman. Very good, Steve. Again, if you want to give us your shipping address here, or we'll email you tomorrow, either or, however you wish to do it, because we got all your information from when you registered. So congratulations. All right. Excellent. That's terrific. That is terrific. Okay, so we are going to stop sharing. All right. And now you should just see the pretty faces of
there you go.
Rick and me, right? Just Rick and me.
Rick and I.
Or me and Rick. All right. What'd you guys think of this tonight? Was it useful for you? Okay, I've got Ted and Todd. Great. You've got me your ship to address. Oh, Ted, North Mankato, Minnesota. How about that? I lived in Prior Lake for 22 years. Drove through,
22.
drove down 169 through Mankato many times, many times. Oh, good, excellent. And Todd from Huron. Okay. All right. Eugene says, Alaska misses you, Rick.
Ah, thank you. Thank you.
But hey, Alaska's loss is Nevada's gain, right? Very good. And speaking of Nevada, Joe Jackson from Henderson, Nevada. Very good. All right,
Yeah.
Joe. Excellent.
Yo.
Excellent. All right. So questions, guys. I am not. I am upset that we did not reach our maximum ugly capacity, says Rich McGrath. Where's Dave? Dave's not here, man. Dave's not
Dave's
here.
gone, man.
Dave's not here, man.
Yeah.
Dave was when I saw Dave yesterday, and when I saw Dave yesterday, it was the first time I'd seen Dave since early February of 2020, right?
Yeah.
Which was the last time I saw you in the flesh too, Rick.
Yeah.
Dave was bent over like a question mark. I mean, his back was killing him. I don't know what he did, but he was in serious
Hurting
pain.
unit.
Yeah, and then he drove all the way home back to Long Island. And last night when we had to go after dark last night, he was so bent over, he was just in serious. He said, "I can't." He had it. Dave had a hip operation about a year ago, a little over a year ago, and he had a walker. That's how that he used it. He still had down in the basement. He had his son go get his walker. That's how bad it was for him.
Wow.
He was walking around with a walker.
Hey,
Um,
tell me this. He wasn't driving the SMAT car, was he?
no, God, no. Then I don't think they ever would have got him out of that thing, you know.
That's
Yeah.
crazy.
All righty. All righty. Well, great. Hey, this was really a lot of fun. And I love the sizing tool, and that's on our website. So
Yeah.
takeocomfort.com, go to the selection tools, and you can use that for it literally 2 minutes worth of effort and input, and you'll be able to get the right recirc pump for the job. And that 1.6 GPM for half-inch copper is such an important number. And for half-inch PEX, I think it was 1.1 gallon a minute is your max, right? I think was that it? Half-inch PEX?
Yeah, it's about 1.1 for half-inch PEX. So again, half-inch really should go out of our vocabulary for recirc lines. So,
Yeah.
but you guys play with it. That's what we're trying to teach you. You guys take a look at what the velocities are, what you can expect to get out of it, and what what kind of trouble you might get into as well. So those handouts, take a look at those handouts. You guys that haven't downloaded them yet.
All right. And here's the other thing is we're starting to hear rumors and rumblings, and I'm sure you're hearing about them as well, that um, there's an awful lot of pipe failures going on out there for PEX, for copper, for things like that. And they have determined it's because they put in a way too big recirc pump,
Yeah.
and the pipe companies are saying, hey, whoa. This is not our fault here. That's why the Copper Development Association has that page 11 in their guideline, and that's why the PEX manufacturers have their own disclaimers, right?
Yeah. Yeah.
Or the weasel clauses or the get out of jail free cards,
Yeah.
So
Yeah.
that it's really incumbent upon the designers and the installers to make sure you go ahead and size that pump properly. Here's the thing. There's no immediate downside to oversizing a domestic hot water recirc pump, right?
Not immediate.
There's no immediate downside. It works, right? Nobody's waiting for hot water. Nobody's complaining. So, and I got a question then for you guys. How many of you who does the programming? Who does the programming? If there's a timer, all right, those little dippy switch timers that come on the pumps, and we have them too, or even a little digital. I know some companies sell a little plug-in digital timer that's a Christmas tree light. It's a Christmas light timer is really what
Yeah.
it is. It's
Exactly.
nothing more than that with the company's name put on it. That's all it is. But it's got 47 pages of instructions. Who sets those things? Who sets those things? Is it does the installer? Do you as the installer set that up, or do you just say, here you go, Mr. Homeowner, you're gonna have to set this yourself because you know your schedule. I'm out of here. And what I've found from talking to a lot of other contractors out there is they don't touch it. They say, hey, homeowner, your job. Okay, I just put it in. You figure out how to use it. or
Yeah.
you figure out how to program it the way you want. And
Yep.
what we've ultimately seen is most homeowners either get so frustrated with programming it that they plug it in and have it run all the time, or they say, "Ah, to hell with this thing," and it's not running at all.
Yeah.
That's what we see, and
Yeah.
that's the beauty of the smart plug, is that nobody has to know how to set it up. It figures it out for itself. Either if it's in the pulse mode, well, that's easy. If it's in the learning mode, well, then it'll learn the customer's hot water usage patterns, and it'll take it from there. So it's kind of solves a problem on both ends.
Yeah.
So you don't have to take a lot of time programming it. The homeowner doesn't have to take out get an engineering degree to figure out how to program it either. You know, and I don't know anybody. I tried to walk through the directions on how to program that Christmas light thing, and I'm not the smartest guy in the world, but boy, it made me feel dumb because it's just, there's a lot of stuff there. Why does this thing have to know when the sun comes up? I didn't understand that part. It needed to know when the sun came up.
Yeah.
Why?
Yeah.
That's it. All right. Uh, Yeah, and Mike says installer sets it up based on prior survey of customer needs. So that's good. Okay. So
Yeah. That's good.
here we have an instance where the installer sets it up, which is terrific. And again, you have to ask the customer what their needs are and what they're looking for. And I've had guys that say, no, we don't program at all. We just give the instructions to the homeowner. They know what they want. They can figure it out for themselves. So, okay.
Well, this would be a good question for Mike. So, Mike, do you see an advantage to switching from a timer to something like the smart plug that says, you know what, I'll still spend some time with the customer, but all I've got to do is tell them, look, we're going to learn, it's not like Big Brother or anything. This little device is going to know when to have hot water in the wall behind the fixture at
Hmm.
the appropriate time. And you don't even have to think about it. Okay. And we're going to shut off when you go to work, and we're going to shut off when you go to school. And we're going to come back on 1 hour prior to when you need hot water. In case you get home 30 minutes early, we've got your water hot already. So
Right.
it just seems like such a better option to at least offer. Maybe
Hmm.
it's an upsell. Maybe it's an upsell for you.
Yeah. Yeah. Or just a standard offering. I mean, really.
Yeah.
I get the worst thing you can do is just install it and plug it in. That's the worst thing you can do. It's the easiest thing you can do and the cheapest thing you can do. And no one's going to ever be upset with that either until the house turns into a sprinkler system. When we've looked at there's three basic customer groups, I think, for domestic hot water recirculation. You've got one end of the spectrum that says, I don't want any excuses and I don't care how much it costs. All I want is when I turn on a hot water faucet anytime, day or night,
Yeah.
I want hot water and I don't want to have to call you to complain about it. So don't
Yeah.
screw it up. The other end of the spectrum, you got a group that says, I'm required by code to put it in. I don't know what the hell it is. I don't want to do it, but I have to. Give me the cheapest flipping thing you can find and put it in so I can check that box off on my list. Uh, the same solution works for both, right? Just a cheap ass pump, plug them both in and get out of there, right? That works for both. Unfortunately, the downside, of course, is you're going to turn this thing into a sprinkler system pretty doggone quickly. So there's that. There's that. The big group in the middle, however, they want they want to conserve. Maybe they don't like the idea of wasting 12 to 14,000 gallons of water down the drain every year waiting for the hot water to show up. That's a sizable chunk of the audience. There's people who says, I don't want to pay for 12,000 gallons of water to go down the drain every year. That's a sizable chunk of the group as well. And then you've got a group that says, I just don't want to wait. I'm willing to pay for the convenience. And that's the big fat part of the bell curve right there. Those are your primary audiences for domestic hot water recirculation. Now, for the people that just don't want any excuses, a properly sized pump on a smart plug in the pulse mode is going to get it done for them. It's not going to use quite as much electricity, which may or may not matter to them. It's not going to make the water heater work harder than it needs to, which may or may not matter to them. but it's a good solution that will protect the pipes. Ditto on the other end too. Good solution that'll protect the pipes. Put it in pulse mode and you're done. Okay. If they really want to go cheap, we still sell an all bronze circulator with a timer, with a little
Yep.
dippy switch timer on it. That's probably about as low end as you'd want to go there. Now, one other question that came up earlier, and I want to get back to it, is someone asked, well, why would you prefer in one of these circulators, what is the advantage, or why would you prefer stainless steel to bronze? And that basically is low lead, correct, Rick?
Well, to the best of my knowledge, and the other thing that the reason we might go stainless steel is because Takeo owns a stainless steel foundry. You're going to
Well,
see a
there's
lot
that
of the
too,
thing.
yes.
You're going to see a lot of the stuff that we do in bronze go to stainless steel. Of course, not the sweat unit. You know, we have some
Right,
sweat volutes. Of course, those are going to stay bronze, but everything else potentially going to go to stainless steel just because
yeah,
it's what's good for us. And most people don't complain about getting anything in stainless steel. In fact, it's
right.
perceived as an upgrade as far as we're concerned.
Right, right. And yeah, you don't, I mean, one of the things about bronze is we very recently had to be upgraded to that from from low lead to like wicked ultra low lead
Yeah.
content.
Yep.
And stainless steel, we just don't have that issue. Okay.
Yeah.
And we have a stainless steel foundry. We can mill those things to, the exact tolerances that we need. And it's really strong for the flanged options, and there's still a big part of the country that use flanged DHW circulators,
Yeah.
flanged circulators for their DHW. If you want to go with threaded, well, we have the 006E3, which is actually a composite plastic body
Yeah.
with threaded connections, threaded union
Yeah.
connections. So there's another option for you there. I
Yeah.
hope that.
Something to that, John. That composite body. That material has been used for years and years. I mean,
Mhm.
that's got a really good track record. People say, "Oh, that's just plastic. I don't want anything plastic." Let me tell you, that's a good little volute. The other, what I've heard, now I can't back this up, but I've heard this unsolicited, that those don't tend to have as much fouling, right? That hard water doesn't tend to stick to the plastic as much as it'll stick to
Mm-mm.
the bronze. Okay, and maybe stainless steel as well. But so there's an option for you. The good thing in Taco's given you lots of options. We've got a composite body that's BSP thread. We got a bunch of stainless stuff that's BSP, and we have that universal flange. Again, personally speaking, I would go with the BSP. It just makes more sense than bolts and nuts
Yeah.
and wrenches and all this stuff. I think now I don't always, John knows where I'm going with this. I don't think the Europeans have much on us at all, other
No.
than that whole idea about a single half union flange on their pumps.
Right.
They've done it up into the bigger stuff as well. And I'm going, boy, I wish North America would take off with that, but I doubt it's going to happen. But at least on the ones that we do offer, start considering that. I think you'll find from an installation service, you're going to love the half union flange. It's great.
Yeah. It's funny you touched on something. It's always been a pet peeve of mine is that a lot of in our industry, and we lived this when we worked for Wurzbo and
Yep.
Uponor, Rick, is
Yep.
there's a mindset out there within our industry, a bias, if you will, that well, if it's from Europe, it must be better because those Europeans know everything. They do everything better than we do. No, they don't.
No, they don't.
No, no, they don't. I'm a member of a very interesting Facebook group. It's called the Hydronic Design Group. That's what they call it. But it's a bunch of hydronic heating guys and women in England, in the UK. And the discussions they have, and these are the best of the best out there. The discussions they have are very interesting. Become friendly with a guy who teaches he owns his own hydronic training school.
Nice.
And he a lot of the things that he says are very interesting. I mean, first off, he would love if we gave him a Delta T pump. He would be as ecstatic as an Englishman could possibly get. I think he'd do the John Cleese funny walks thing everywhere. I mean, he'd be so
Yes.
happy. But they really are. what pump do they put in? The one that works, the one we've always used. They're not really into pump sizing. I tried to get ask some questions about how do you size pumps. Well, we use what they give us, and they don't get into sizing, or anything like that. So it's very interesting. It's very, very interesting what they know and what they just do. A lot of the things that they do, a lot of the reasons they install the types of systems that they do is simple. It's because that's the way they've always done it. I remember having a discussion. I was on this discussion panel once at a trade show, and it was really funny. And the guy was saying, "Well, that's how they do it in Europe. Those Europeans, they use those thermostatic radiator valves and panel radiators because that's proven to be the most comfortable. That's how they do it in Europe." Yuck, 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 yuck. And I'm looking at him and says, "That's not why they do that in Europe. Well, the reason they install those systems the way they do is because that's the way they've always done it.
Yeah.
And the reason that's the way they've always done it is that's how they started doing it when they were retrofitting existing homes in the 60s. You really got to read and learn. Don't just blindly assume that because they're European, yuck, 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 they do it the way they do it, because they've got, hydronics has about 90% of the market share in residential, home comfort over there, simply because they haven't thought about air conditioning yet. But I bet you that's going to change, Um, but it's just funny. It's just really, really funny how people think that way. And here's another fun fact that you might have, right, Douglas, you're absolutely right. Yeah, that's funny, but not okay. But they had a little setback in the early 40s all throughout Europe.
Yeah.
Yeah, and things had to change, and that's part of it. But they did not have a residential building boom right after the war either. They didn't have a residential building boom in Europe until the 70s, which should tell you something. They were busy rebuilding the infrastructure and communications and all of that, and then the commercial industrial complex so people had places to work. They didn't get around to building new houses until the 60s, until the late 60s, and well into the 70s. But where was I going with this? Oh, yeah, kind of some interesting news that we've received that, but if it hasn't happened already, Takeo is really, really, really close to becoming the second largest circulator manufacturer in the world. Yeah, I just heard that the other day. We are very, very close to becoming the second largest HVAC pump and circulator manufacturer in the world.
How do we know that, John?
We know that
How do we know that?
we know that through statistics in North America as well as in Europe.
Yep. Very
Yeah,
good.
so that's pretty cool. That's
Very
pretty
cool.
cool. Yeah. Who do you have to knock out to get to number one? Well, for the past 8 years, 7, 8 years, we were number three behind Grundfos and Velo.
Yeah.
But we are in the process of putting Velo in the rearview mirror right now, which is really exciting. And
Yes.
and that's thanks to we have a really growing European brand in Europe, Takeo Italia and Takeo Nova,
Yeah.
which is going to be growing a lot over the next several years, and it's going to be an exciting journey. So that's pretty cool. That's very gratifying, And
Yeah.
this little company from Cranston, Rhode Island, that could, that's very I don't know. It just excites the hell out of me, and I'm very, very proud to be part of it.
Woo!
Yeah.
Yeah.
Yeah, and those efficiency ratings, absolutely. Yeah, the efficiency ratings are huge, absolutely huge. That's going to change things in this
Yep.
country a lot. For those of you who don't know, we just released, well, the first edition of the summer series was on the Hydraulic Institute and their new energy efficiency labeling for circulators. And Takeo has 5 of the 6 highest rated residential circulators in the business. And we're well ahead of the next group. So the highest rating that anybody is able to achieve right now with current technology was 188. That's bigger. It's called the ER, the energy rating. The higher the number, the better. So there's a bunch of circulators. There's 6 circulators at 187 and 188. All right. Takeo has 5 of them.
Nice.
Armstrong has the other. The Armstrong Compass is the only other one that's in that neighborhood. Everybody else is at least 6 points behind us. Most of them are there's only one pump that's 6 points behind us. The rest are about 9 to 12 points behind us in terms of efficiency. And that's independent testing, independent third-party
Right.
verification by the Hydraulic Institute of Performance and Technology. And the
Yeah.
other cool thing that the Hydraulic Institute and the Department of Energy, the US Department of Energy, has verified is that delta T variable speed pumping is the most efficient and the most effective way to run a variable speed circulator. It's not delta P, delta T. It's temperature responsive, and it's about 20% more efficient than delta P, which is really
Yeah.
remarkable in terms
Feather
of,
in the cap.
yep.
Yeah.
So that's pretty doggone cool. Those things make me happy. Oh, Kevin's got a little statement
Yeah.
here. Your
Yeah.
technical support for me has been amazing on the hydronic side, helped me solve a whole building problem, turned out to be wrongly sized equipment, and your universal flanges saved me hours of work. Well, cool, Kevin. Thank you.
Right on, Kevin.
I'm glad it worked out. And I'll pass that on to the tech services department. They love hearing
Yeah.
stuff like that because I tell you, tech services is
Unsung. Yeah.
unsung heroes of every company. I'm telling you, because you really have to be a special person to work in tech services, because every time you pick up the phone, it's a problem.
Yes.
You
Yeah.
know, you want to, I challenge everybody here. All right, everybody who's still on, do me a favor. Over the next several days, call up the Takeo Tech Services Department and just say, hey, I wanted to tell you guys something. You guys are doing a great job.
Yeah.
And
And
see
don't
what they
say anything
say.
else.
Don't
Yeah.
say anything else. Just see what they say. You guys are doing a great job. Products are fantastic. Nobody ever does that.
You're going to
Every
hear silence on the other end.
Yeah,
We
somebody might faint,
yeah.
you know, somebody might faint, but they really are terrific, and they do such a good job, and it's such a hard job because you get beaten down every day. You deal with problems, and
Yeah.
nobody's ever really happy on the other end of that phone, you know.
Yeah.
So it really is a thankless job, and fortunately, we've got some of the very, very best in the business. And seriously, if you call them up and say that, they might just have a heart attack. You're right, Richard, but it'll be they would appreciate it. They would absolutely appreciate it, and you know it would be a good thing. And I will let the boss over there know about your comment and your good experiences. That would be terrific.
Thanks. Yeah.
All right. Who rated the Delta T pump? That was the Department of Energy, the
Yeah.
United States Department of Energy. Yeah. They rated all different types of control strategies for standard efficiency pumps and ECM. And Delta T, temperature differential control, was far and away the highest rated in terms of efficiency and effectiveness. So yeah, because it's the only form of control for a variable speed circulator that will speed the pump up and slow it down when zone valves open and close, which a delta P pump will do as well. You know, it'll open and, you know, it'll speed the pump up, it'll speed it up or slow it down on that very basic mode of operation, but it'll also speed it up and slow it down based on how cold it is outside.
Yeah.
And it doesn't have an outdoor sensor or anything. It's just how much heat's being taken out of the pipe to be put into the room. And that's going to change based on how cold it is outside.
Yeah.
So as a zone pump, if the zone is in fact large enough as a zone pump, it'll vary its speed as a
Yeah.
zone pump, which a delta P pump won't do. A delta P pump will find its happy space and go one speed, right? As Rick says, it can't. As there's nothing to create a pressure differential in a single zone, right? Or
Right.
pressure differential change in a single zone.
Yeah.
So as it gets warmer and colder out, as a zone pump, it'll speed up and slow down, but also as a zone valve pump, it'll speed up and slow down. Now, what you're going to have most cases is a good chunk of the heating season, that thing's going to be running in its minimum speed, which is about 9 watts. All right.
Yeah.
Which if you can heat a house either with zone valves or as a zone pump with a 9-watt pump, man, that's you are well ahead of the game. Okay? You're not going to have that 20-degree delta T, but hey, you're going to have it's not going to be a 2-degree delta T. That's the thing.
Yeah.
Bob says, yeah, as a zone pump, it is kind of expensive. Yeah, it is. Yeah, it is. But it's also the closest thing you're going to find in this industry to a self-sizing pump. In fact, it's
Yeah.
the only pump that can actually claim to be self-sizing.
Yeah.
Okay, Delta P is not self-sizing. I don't care how many times you push that active adapter auto adapt button. That's not what it does. All right, it's not a self-sizing thing. So yeah, it is kind of expensive, but it's the only pump you're going to be able to buy that will be self-sizing. So
Yeah,
if you do a lot of if you do a lot of pump replacements and you don't know what to put in, you put this in and
yeah,
let it rip, you know?
yeah. That's cool. Hey, got a shout out to our reps. They're other unsung heroes that help
Yes,
people out,
indeed.
and of course Douglas is talking about one of them there, Emerson Swan out east. Uh, Again, our reps do our most of the work. Sometimes I'm amazed at the amount of hands-on, feet on the street, that sort of thing. In fact, I'm not ashamed to say that I've learned lots of stuff from our reps. Right? They have just so much more, penetration into their areas of expertise. Remember, they've got pump line, they got boiler lines, they got
Hmm.
control lines, they got valve lines, and they know how those systems work, and they see these little nuances and stuff. So again, remember your Takeo rep. Your Takeo rep is really really good at what they do.
Hmm.
Again, I can't say enough about them.
No, absolutely not. You're absolutely right, Rick. Richard says, this subject does to me what PDBV discussions do to you. Richard knows me well. You want to talk about pressure differential bypass valves? Watch this fella's blood pressure go up before your very eyes.
Yeah, yeah.
Oh boy. And you know what? One of the happiest things that has happened to me in the past year and a half, Rick, you know what it is?
Yeah, tell me.
What is it? Oh, it's Takeo took our pressure
Oh, yeah.
differential
Okay.
bypass valve is out of the catalog. We don't sell them anymore.
You know what? I never paid any attention to them, so I didn't even notice.
Right.
So that goes right along with it, right?
Oh God. Well, you put in a pressure differential bypass valve. Oh God, please.
Yeah.
Anyway, and also, another thing, did you know, Rick? I think you did. That years and years and years ago, Takeo was in the thermostatic radiator valve business.
I remember selling them with
Yeah,
American Plumbing and Steam in Anchorage, Alaska.
right. We owned a company
Yeah.
was out of Connecticut that made those things, that manufactured them. And we eventually sold the business because anybody care to guess why? Nobody bought them.
Yeah.
We don't install those kinds of systems here, not to any great degree,
Right.
to the point where it made sense to to keep the company in our portfolio. So we don't we didn't we I remember getting some clown on LinkedIn was saying, well, why don't you take a leadership role and promote thermostatic radiator valves because they're better. They're not better.
Yeah.
B, been there, done that.
Yeah.
Okay.
Yeah.
Just those are the kinds of people, those are the kinds of things you hear those and you go, oh, learn.
Hey, let me clarify, or at least add to. There's nothing. We're not saying anything wrong with
No, no, no,
panel
no,
rads.
no,
By
no,
by
no, not at all.
just the control of the heat into the room through that emitter, there's better ways of doing it.
Mhm.
So again, don't get us wrong there.
Right, and really thermostatic radiator valves and panel radiators, again, that's what they use primarily in Europe, and they are terrific. They work okay. People are fine with them there. I always wondered about the logic, and I know they're calibrated, I get that, but the logic behind having the thing that controls the comfort level of the room about that far away from the hottest thing in the room. I just always made me scratch my head. You know, maybe I'm not the brightest light in the power grid, but it's just, it just made me wonder.
They
It's
would tell you they would tell you it's calibrated accordingly.
Of course it is. Of course it is.
Yes.
And people would move, and if the system wasn't sized right, if you left this room, you'd turn that thermostatic radiator valve down, and then you go to the next room and turn it up. I
Uh-huh.
don't want that much interaction with my heating system. And that's maybe because that's the way Americans are and we're quote unquote spoiled. But I just want to turn that thing, set it to a temperature and not have to worry about it. I don't want that much interaction with my heating system. And I'm in the business, right? Yeah.
Yeah.
So
Hey,
anyway,
Bob's got
anyway.
one here.
Yep.
No, no. Oh, Kevin, when these things populate, it shifts up, and you might be looking at a combination of two different questions. But I think Kevin's asking off topic, but Takeo getting into becoming monitored with building management systems. Would be nice to get that granular information from the building. Okay, all right. Well,
Yeah,
yeah,
there is,
I
I mean, there is still a wing of the company that is into building management systems and controls for commercial structures.
yeah,
Residential, but that's not really going to be in our wheelhouse. But yeah, there are there's still and they changed the name of the product and I forget what it is. That's how little contact Rick I have with it. Rick might have a
right.
little bit more. But
No,
yeah, there is. It was the former iWorks. It is the name of it has been changed, and I'm not entirely sure to what. If someone told it to me, I'd go, yeah, that's it. But I can't remember that.
yeah,
I
it's a
only I only
niche.
have so much random access memory left. Yeah.
But Richard, you're on the right track there. But the
Yeah.
name has changed.
Yeah.
So,
Douglas says for about thermostatic radiator valves, how well do they work when you push the sofa up against it? Well, yeah, but that is the radiator or neither the radiator nor the valve is going to work that well. But then again, baseboard's not going to work that well either in that case. Yeah. So what else we got? We got a lot of good questions. A lot of good questions. Here's Laura Winkler says, I just had a call about a thermostatic valve this week. Had to tell them Takeo doesn't make them anymore. Send them to Danfoss. Yeah, Danfoss does a terrific job with them.
oh, absolutely.
Yeah.
Yeah.
Yep. Yeah. So cool. All right, we got a lot. So a lot of folks still in line. We do appreciate this. This is a lot of fun. Problem with panel rads is they really need to be hooked up to a manifold so you can just adjust the flow individually. Yeah. Again, a lot of times that TRV will help you if that's what you're doing. It'll open and close based on the comfort level, and they can balance each other out. And the thing about the manifold too is it's like with radiant floor heating. A lot of people think, oh, we got to adjust the flow to each individual loop and get it down to the 0.3 gallons per minute or whatever. I don't know about you, Rick, but through all the years at Wurzbo, everything we came up with, no matter how fancy it was all we're trying to do is make the water think all the loops are the same length. That's
Yep.
really all we're
Especially,
trying to
well,
do.
yeah, when it's all one zone.
Yeah.
What we had to our advantage is the ability to put a telestat on there
Hmm.
and actually get every room have its own zone. I mean, it's a
Even then,
wonderful.
you still had to get them balanced,
If they
right?
were all open at the same time,
Yeah.
you had to make it happen for you,
Yeah.
balance it out as best you
Yeah.
can.
And that's what they mean by balance. Just think of
Yeah.
all the loops. Trick the
Yep.
water into thinking all the loops are the same length and everybody's a happy camper. Yeah,
That's right.
that's it. Even when we came out, remember that
Resistance.
little clip-on thing we had
Yeah.
on the little tail piece that was supposed to
Yep.
tell you the GPM and you adjusted, you got it to the GPM, which was
Yep.
great until you went to the next one. As
Well,
soon as you,
you got to see that dynamic balancing.
right,
Yeah, right. You change one thing, you just changed everything you just set up.
that's right,
So,
that's right.
yeah, that was interesting.
It is
And those
crazy.
were great, John, until the windows got dirty, right?
Yeah, that's right, that's
And
right.
because they used light, and if you couldn't see the light anymore, you couldn't balance anymore. It was like,
And
oh,
and we know there's the manganese in that water would coat up. I mean, it was great. That's why PEX turns gray, right?
yeah, yeah,
I've walked into houses where the PEX had turned so gray. I swore to God it was polybutylene until I
right,
touched it, you know?
right.
Yeah. Oh boy. Anyway, what other questions you have out there, folks? All right, let's see what you got. This is good stuff. This is good stuff. Douglas is taking off. Got a few things to get done. Good for
Thanks,
you.
Doug.
Do appreciate an hour and 47 minutes. You've done your duty tonight, Doug. Thank you, sir.
Right.
We do appreciate it.
Yeah.
We do appreciate it. All righty. Good night, and a good night to Mr. McGrath. Always a pleasure.
Richard,
Do enjoy spending time with you. I can't wait to see
good
you again.
name.
I see you again in the flesh. All right. And Bob's taking off as well. So I'm gonna guess it's time to say good night. What do you say, Rick?
I'm I'm good with it either way.
All righty. I think we should
Yeah.
say good night. Everybody's got stuff to get to. We'll see you next week. Next Tuesday night, we will be repeating this presentation live at 9 p.m. Eastern. Rick will not be with us, so Dave and I, it'll be Rick's not here, and it'll be Dave and I as Butch and Sundance. And then next Wednesday night is the next brand new Takeo After Dark. I want to go back and see what's the show next week.
Here, I got it right
I
here.
got it right here
Somebody else.
too.
Okay.
Oh, the real, nope, which one is it? Dun-dun-dun-dun. Flow head and circulator sizing fundamentals for residential hydronics.
And you're on the hook for that one, man.
Oh, baby,
Mr.
I can't
Barba,
wait.
the man. The
Oh
legend.
baby, oh baby, oh baby. Yeah, that we might very well be doing that one live from the factory.
Nice.
Well, either
Nice.
Tuesday nights or Wednesday nights. I'm not sure which. Because we have we're gonna be at the factory for a meeting next week. So the Tuesday night show is going to be from either the factory or the hotel we're staying in. Maybe Wednesday night show. Maybe we'll set up shop out on the factory floor. See how the Wi-Fi is out there. Would that be cool or what?
That would be cool.
Yeah, let's do. Maybe we'll see about doing that. We can get the green light to do that. All righty, folks. Hey, thank you all. Have a wonderful evening. Rick, outstanding work once again. And there you go, my man. We will see you all next week. Have a great rest of your week and weekend.
Later.
Take
Thank
care.
you all.